Hello everyone. We'll be looking into this PR today. PR is to add witness mutation check inside FillBlock. So yeah, let's dive into it. So what's the PR about? Okay, so the PR is about the check to not allow mutated blocks to be processed immediately when it is received. Uh, Currently, it is only done for legacy block messages, but since SegWit, we also have compact blocks, and the check is also not uh, right now working for past segment blocks. So this PR adds the implementation to for the segment blocks also to be checked for this mutation malleability. Okay, so we'll dive into the code. Yeah, so we are adding a segment active flag inside the parameters for the fill block. This is to ensure that if we have a segment active, uh, if we have a block that is after segment active and we want to check for the malleability, we will just trigger this flag and the implementation would change according to that. So this is the code that has been removed. We initially had a state, block validation state. These can be anything like this block mutated, accepted, etc., etc. Okay, so this is something which is intriguing to check. What is this check block function and this check block variable? So looking into the code, we'll see check block function. Yeah, this is the code that we have currently. Uh, and this is the check block uh, variable. This is a pointer, and this is the function itself again. So what is the check block function? It is a function signature. So as you can see here, I'll just increase it. So you can see we are naming a particular function signature here. So if any function that follows the same format is being used, we can just use check block function uh, instead of this. So we are naming this function signature, and then we have this mcheck block mock pointer, which currently has a null pointer. This is to initialize a pointer. So when there is a null pointer, what would happen is this will do a check block implementation for debug builds and for not real world scenarios. This is really important because doing check block in real world scenarios is very costly, and we will be using like wasting resources if we are checking in debug or test builds. So we have a pointer to specify that. So what happens here is we check if this this is wait a second. Okay, so we check if this pointer is null pointer, uh, and if it is, then we go for this. If not, we go for the real check block implementation, which is the actual check block implementation that goes on in the real code or in production. So this is what it is. We'll not go deep deep into it, only if we have time. Yeah. So this is what happens in test scenarios. This we have this check block mock, and in real world scenarios we have the real check block implementation. So if in the previous code we would have found that uh, this check block is not returning true, check POV is true, and check multiple root is also true, we'll go into this function. This is just everything that I explained right now, that this check block function is really expensive and should not be used in test builds. So what we see is if we are going into this this part of the code, we'll see if we get the result as the block has been mutated. So if the block has been mutated, then we had a short RD collision. Short RD collision means two inputs are raising the same uh, outputs for the function, and we have a read status failed. The other is if in general we got into this functions scope and this was not the case, the block was not mutated, then we had a check block field. So the check block did not go through as we would have liked it to. Now, removing this, we'll have the only check for is block mutated function, which has a different function signature. So you can see there here. Okay. So is block mutated function does have a different signature now. We have a C block and a bool check and check block mutated mark in place of the uh, here mcheck block mark pointer. So we have changed the function signature. We change it with check mutated. This is the same logic that we had in the previous line. We check if we have a null pointer here and we are going for the check test fields. If we are going for the test fields, then we go into this. Otherwise, we'll go into this is block mutated function, which we'll see that we don't have to specify the status check block field. This is only for the FillBlock implementation, and since we have removed this check block function in the FillBlock implementation, we don't the need for this, and this will be removed further in the code. So if we see that the block has been mutated, then we'll return a status failure of like we can't read the block because it has been mutated. Reading the block is futile or does not have like is the wastage of result. So this read check block failed has been removed since it was used for the check block implementation in FillBlock, which has also been removed. This is the change of signature we talked about, and the change of the FillBlock signature where we are adding segment active bool parameter. Now this is the second important part which goes into the P2P processing. So we have this block index for the previous block. We do a check here that we look for the block index of this partial block header and we look for the block index of this particular block and we share in the pointer and go into the FillBlock implementation and with to check for the deployment we see if the block that we are talking about has been mined after we deploy the segment. So going into this function, we can go for deployment active after. Uh, we have this. This is important in deployments because their uh, Bitcoin is a project which is very very which has been introducing a lot of changes, and there have been forks, soft forks, which needs different deployments, and which we would like to mark on which block or when they were deployed in the code or on the blockchain. So we have this deployment active after function, which returns a bool that it was deployed after a particular consensus uh, change, which has been noted in this deployment height function. We do some basic checks that the deployment that we are asking for is a valid deployment in consensus, and some basic checks, and then we see uh, if the index of the block that we are referring is greater than the index of the block that has been marked here for the deployment of the particular consensus change that we see, that we would like to see. So here you can see the deployment changes in height SNB, the BIP34 height, the BIP65 height, BIP66 height, CSV height, and the segment height. So this is the particular case that we are interested in. You can see in the code that we are checking for the consensus of the we are checking for the segments deployment height. So if the block has been mined uh, after this segment deployment, this will return true, that the segment is active. Otherwise, it will return false. So looking into this function, so what assume is like it is basically an assert statement, but it is lighter on the note that it is a softer assert statement that will not result in an error, but something like of a warning, which is not very uh, which is not very threatening when we are going in production builds. So this is kind of a check here, and we see we check uh, we get the index of the previous block that we want, that we are interested in, and we then just throw it into the FillBlock function. So a lot of comments have been removed. So earlier we would have to, yeah, so I think the change here is because of this having gone this far in the compact block processing. It is we we should not have gotten this far in compact block processing. It's attached to a non-header. So the fact that we have reached here is the fact is proves that it is a valid block, and having gone through this deep in the code, it might be a valid block, but it might be a valid block, and we should not do a lot of checks since they have been checked before, which were done by earlier read status check block field of bad proof of work, Merkle root not matching the transactions given, and the block is invalid. So these three checks have been removed since we are calling the fill block after this much processing has been done. This is because compact block, since even after we are getting only partial block, we can do block processing on it with us filling our transactions in it. Like here, we get the block and we fill it with transactions that we get either from our mempool, someone else's mempool, or someone send it to us. So this processing or these checks have been removed, and the block is okay for further processing. We again look up for the index of the previous block. We do a safety check, and then we do FillBlock again. This is uh, amount to this. So now we are going into the test changes of the block encoding slot test. Since we have changed the signature of the function FillBlock, we have to change these two, and we are checking for uh, this segment active implementation of it. So when the segment active is true, or when the block is not a legacy block, we want to check if the uh, checks are working as they should. So these are trivial changes. A trivial change here again, here too, and we are asserting based on the uh, conditions that form. So here it should be a read status invalid because there are no transaction. Here it should be uh, yeah, here it should be a read status okay because it everything is okay. Read status okay here. Yeah, now going into this check block function has been removed. We check is block mutated function with the plus is block mutated first test, and we go into the bool result. So you can see that we have simplified a lot from the previous, since now we don't have to check for block validation results of the check block implementation. We only have to check if the block was mutated or not. We can now only return bool results. So this is a welcome change. And you can see that we are not naming anything here, and we are just getting a result. So this is C++ quirk where it knows the implementation of the is block mutated function signature, and whatever implementation we call it like this. And when we want the result, we can just in this square brackets can ask for the result or the output from the function here. This is the quirk of C++, where we don't have to now do the full thing that we would have to do when we are working with any other language. Again here, we are like here we had this check, but we would also have to return if the state was invalid or not, and return true if it was okay. Here we are only returning the result. Here this code has been removed since we don't have to do the check block uh, checks, and we don't care about these block validations result anymore. So these checks also have been removed. We just take a segment active bool from the first data provider, and is block mutated bool which, uh, which is just a precursor for uh, taken in a first input if the block is mutated or not, and with then we do the check of is block mutated with the fuzzer, and we get the result here. So if it is, not like if we get a result, if we get a valid pointer here, then we'll do a valid production check. Otherwise, it uncheck block mutated mark is the null pointer itself. We have a fill status here with segment active, and we do this checks instead of now fail check block variable. We are just checking into the fail block mutated variable, which is we are getting from here. Yeah, so this was about the code. If we want to look further into it, we can. So going into this check block implementation, we can say that the block is, if it is checked, return true. We are bringing in a lot of validation results here, 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 which were a bit annoying to handle before, but now we don't have to do it. We can look for the variable introduced here. It uh, was this block mutated. You can check if this has a function signature, not mutated. Yeah, we have this. So this is, look, this is also a function signature, a function itself, and we are just throwing in bools here. We just have log debugs of the block consensus, and this is a very pleasant and easy to review code. That only checks for block malleability, block mutation, and is okay for both legacy blocks and uh, after segment blocks. So this was the change that was introduced here. We can now go into the functions, uh, the, the questions of the today's review club. So what is check block function and is block mutated function? And how are they helpful? So we saw that the check block function was the name we gave to this particular signature of 5 parameters, and is block mutated function is also a name given to a particular signature which has fewer params than this check block function. The difference here is that we don't have to check for the status of the check block, and we only check for the mutation of the block. This by just checking if the Michael roots match or not. And how are they helpful? So as you can see, this is kind of like sugar coating the particular function signature so that we don't have to write the function signature all the time. We go for the function itself. So since we have named the function signature, we can use it like we did in the PR that we can look here. So yeah, I like this. This is not generally something that is uh, that that is done for functions, but this is kind of a sugar coating mechanism that C++ provides us to make our code more manageable and like more easier to review and look at. And what does deployment active after function checks? It checks for if the consensus deployment that we are looking for uh, is after or before the the index of block that we are interested in, and how is it important for systems like Bitcoin. So as I said, uh, when Bit, uh, protocols like Bitcoin may want to remember whenever a particular consensus change happened, and we would like to bookmark it and use it for particular scenarios. This is what uh, that it is helpful for. We can check with this that a particular consensus change deployment uh, happened on which block, and we can query it and check with it if our block was mined after or before it. This also uh, this differentiates uh, our logic for whatever we would like a block to be treated with. So like in the case of SegWit deployment, we would like the check block. We would like the block mutation check for legacy blocks, while if a block is mined after the segment change, we would like to incorporate a block mutation check, which also accounts for the witness in the transactions. So what does FillBlock does? So FillBlock, so we have a particular set of transactions, and we also have a partially filled block, a partially downloaded block. What we do is we take the block, we process it, we add our own transactions that we want, and then we create a full block from it. So this is what full block does, and this is particularly helpful for uh, creating a full block from compact block that we receive in the relay. Yeah, so this was about it for the review club today, and thank you.